How to create enormous amounts of datasets using OpenAI's GPT for building a new large language model, LLM, using those datasets. Creating enormous amounts of datasets using OpenAI's GPT models involves a combination of techniques and strategies. Here's a detailed guide on how you might approach this. 1. Understanding the process. GPT models. Models like GPT 3.5 Turbo or newer versions like GPT-4 can generate text based on prompts, which can be used for dataset creation. Dataset types. You can create datasets for various purposes like text classification, natural language understanding, data augmentation, etc. 2. Strategies for dataset generation. API utilization. OpenAI API. Use the OpenAI API to programmatically generate data. This involves prompt engineering, crafting precise prompts that guide the model to generate the type of data you need. Batch processing, send multiple prompts in batches to generate large volumes of data efficiently. You can automate API queries, potentially using multiple accounts to manage rate limits and avoid detection if necessary for very large datasets. B. Fine-tuning. Fine-tuning models. If you have specific domain data or need tailored responses, fine-tune the model with your dataset. This can help in generating more accurate or contextually relevant data. Steps. Prepare your data in a format suitable for fine-tuning, e.g., SONL files with prompts and completions. Use the OpenAI fine-tuning API to train the model on your data. C. Data augmentation. Generate variations. Use the model to create variations of existing data for tasks like text augmentation. This can help in increasing dataset size by generating paraphrases, translations, or different scenarios from existing data. D. Synthetic data generation. Frameworks. Develop or use frameworks like Sensei for generating synthetic data tailored to your needs. This involves setting up system contexts that dictate the type and style of data generated. 3. Technical considerations. Resource management. Computational power. Ensure you have access to sufficient computational resources, as generating large datasets can be computationally intensive. API costs. Consider the cost implications of using the API at scale. OpenAI provides pricing details for different models, which you should account for. Data quality and bias. Quality checks. Implement quality control mechanisms to ensure the generated data meets your standards. Bias reduction. Be aware of potential biases in generated data. You might need to adjust prompts or use diversity in input data to mitigate this. Storage and handling. Data storage. Plan for storing large datasets, potentially using cloud storage solutions for scalability. Data formats. Choose appropriate data formats for your use case, CSV, JSON, etc., considering ease of use and compatibility with downstream tasks. 4. Automation and scaling. Scripting. Write scripts to automate the data generation process. For instance, Python with libraries like OpenAI for API interaction can be very effective. Parallel processing. Utilize parallel processing or distributed computing to scale up the data generation process. 5. Legal and ethical considerations. Data privacy. Ensure that the data you generate does not inadvertently include personal or sensitive information unless you have the right to use such data. Copyright. Be mindful of copyright issues, especially if your dataset includes or is derived from copyrighted material. By integrating these strategies, you can effectively leverage OpenAI's GPT models to create vast datasets tailored to your specific needs, whether for machine learning tasks, research, or application development. Creating a new large language model, LLM, using datasets generated by OpenAI's GPT. Creating a new large language model, LLM, using datasets generated by or including data from OpenAI's GPT involves several complex steps. Here's a high-level overview of how you might proceed. 1. Dataset preparation. Data cleaning. Ensure your dataset is clean and formatted correctly. Remove or anonymize any personal or sensitive information, handle duplicates, and normalize data where necessary. Format. Convert your data into a format suitable for training language models, often JSON or text files where each line or entry represents a single data point or document. Size and diversity. Your dataset should be large enough, typically billions of tokens for state-of-the-art models, and diverse to cover a broad linguistic spectrum. 2. Model architecture selection. Architecture. Decide on the model architecture. Transformers, particularly those based on the encoder-decoder or decoder only, like the original Transformer, or models like BERT, Roberta, or GPT, are popular. Customization. You might choose to start from scratch, or more commonly, use a pre-trained model and fine-tune it to your dataset. This approach can save significant resources. 3. Software and hardware setup. Frameworks. Use deep learning frameworks like PyTorch or TensorFlow. Libraries like Hugging Face's Transformers can be invaluable for both training and fine-tuning. Hardware. Training LLMs requires substantial computational resources. GPUs or TPUs are necessary, with multiple units often used for parallel processing. Consider cloud services like AWS, Google Cloud, or Azure for scalable computing power. 4. Training process. Pre-processing. Tokenize your text into tokens that the model can process. This might involve using subword tokenization like BP, byte pair encoding, or sentence piece. Hyperparameters. Define learning rate, batch size, sequence length, number of layers, attention heads, etc. Hyperparameter tuning can be one of the most time-consuming parts, but is crucial for model performance. Training. Batch training. Train your model in batches. Use techniques like gradient accumulation if memory is a constraint. Learning rate scheduling. Implement learning rate decay to improve training efficiency. Regularization. Use techniques like dropout to prevent overfitting. Checkpointing. Regularly save model checkpoints so you can resume training if interrupted, or to keep versions of the model at different stages. 5. Evaluation and fine-tuning. Validation. Use a subset of your data for validation during training to monitor performance. Fine-tuning. After initial training, you might fine-tune the model on a subset of your data or on entirely new datasets to specialize the model for particular tasks or domains. Metrics. Evaluate using metrics like perplexity for language modeling or task-specific metrics for tasks like text classification or translation. 6. Deployment and scaling. Model compression. Techniques like quantization, pruning, or distillation can be applied to make the model lighter for deployment, especially on less powerful hardware. API development. Create an API for your model if you intend to serve it over the web or integrate it into other services. Scalability. Consider how your model will handle real-time requests, possibly using model sharding or multi-model serving solutions. 7. Ethical and legal considerations. Bias. Implement checks to mitigate biases introduced or amplified by your model. Privacy. Ensure that training data does not include unauthorized personal data. Licensing. Check the licensing of any pre-trained models you use and understand the implications for your model's distribution or commercial use.